here. So suppose we have function g of x is 3x minus 15. We're going to make this the fastest review you've done. If I have g of negative 10, is that negative 10 an input or an output? It's an input, which means I'm going to put negative 10 in the function for x, and I'll have 3 times negative 10 minus 15. Now, you can evaluate that and write it down in multiple steps. You can type it in your calculator. You can do it in your head. Did I give you the wrong thing? I didn't give you enough? I need one more. Okay. I'll pause this while I get is the answer when you simplify it. Negative 30 minus 15. Negative 45. All right. We're good with that, right? Not difficult. How about the next one? It says find the value of x. So we read carefully. We know that we're looking for the value of x. Hold on. When g of x is 45. Is that 45 an input or an output? It's an output. So am I allowed to put the 45 in the x? No. What do I do with it? And it equal to the equation. So I have 45 equals 3x minus 15. And I just solved for x. I know you did this yesterday, which is why I'm going to talk through the solving part. 45 plus 15 is 60. And when I get x by itself, what would be the input value? 20. So that means that 20 is the input value that gives me an answer of 45. Easy? Should we pump it up a little bit? I don't need to waste your time doing the whole class of that. And if I do, maybe we're not in the right spot. Let's see. We have 3 equations, 3 functions, f of x, h of x, and k of x. We're going to use all 3 of them, sometimes all at once. First, we're going to start simple. I need to evaluate 2 f of 3. So what do you think that means we have to do?
Multiply our f of 3 by 2.
Yep. So first I need to find what f of 3 is. So I'm going to use this function f of x right here. And I'm going to evaluate it. Now, when you're doing this on your own, you can skip as many steps as you want. But for our class purposes, I'm going to write everything down. So I'm going to put 3 in the function for x. So I will have 3 squared minus 3, which is 9 minus 3 equals 6. So that's not our answer, though, because we are trying to find 2 times f of 3. Well, f of 3 equals 6, so what's the official final answer? 12. There you go. That one's not too tricky. I think the whole front is really not too tricky. All right, B, 1 minus k of 1. Well, which function here is k? The graph. So I find k of 1. That 1 is an x value. And what's the output for 1? Negative 2. So I'm going to write this all down at once. I'm going to take 1 minus, and then k of 1 was negative 2. You have to make sure you write both of those negatives. Well, what happens when you take 1 minus negative 2? You get 3, and that would be your answer. Nothing hard on those first couple, correct? All right, let's try the next couple. C, k of 4 times k of negative 4 times h of negative 3. So k of negative 4. So where's my graph again? What's the output value for negative 4 here? 1. All right, so we know that k of negative 4 is 1. So now we have to find h of negative 3. So h of x uses the second function in the box. Let's see, h of negative 3 is negative 5 times negative 3 minus 7. What does that equal? 15 minus 7, 8. All right, so our final answer takes 1 times 8, which is 8. Now we have a quotient. This should all be pretty simple arithmetic if you can do function notation so far. So h of 7 is that function on the right again. So what do we get when we put 7 into that function? It's just that simplified of these. Negative 42, right? Negative 35 minus 7 is negative 42. And then f of 1. So I used pin for f of 1 before. Let's see. F of 1 is 1 squared minus 3. What's 1 minus 3? Negative 2. So if I find the quotient, I have negative 42 over negative 2 and get a solution of 21. Alright, none of those four really bad. Even the last two really aren't, but they make things look a little more complicated because there's some more brackets and like squares and exponents. Let's start with E. 6 of f of 0 plus h of 4 squared. So first find f of 0. F of 0 is going to be 0 squared minus 3, which is negative 3. Okay, and then h of 4. So let's see. H of 4 is negative 5 times 4 minus 7. Negative 27. Okay, so now we have to carefully make sure that we get everything put back in correctly. So we'll take 6 times negative 3 plus negative 27 squared. I don't know what negative 20 squared, well I do now because I taught this fourth period, but normally I don't know what negative 27 squared is on the top of my head. Can you tell me? Yeah, oh, yes, you're right. 729. Did anyone get a negative when you typed that in? I can't talk and write at the same time. I'm sorry. Let me write it first, and then I'll ask you. Did anyone get a negative when they typed that in their calculator? Yeah, I'm sure somebody did. In fourth period, they were really vocal about it. Let's take a digression here. Step back, sidestep, talk about your calculator real quick. This is my favorite calculator digression. Yes. Do you know? Okay, how do you do it?
I don't know.
Parentheses. Yep.
And then the minus here, and then, yeah.
Yes. So why do I have to do negative 27 in parentheses, and why can't I just type negative 27 squared? Why do I get different answers? Yes. So your calculator, this is my favorite line about calculators, they're really cool, they do great stuff, but they're dumb. They're stupid. They're just computers. They can't read your mind. What your calculator is doing right now is it is doing the order of operations. It is treating this instead like negative 1 times 27 squared. So it's squaring the 27, then making it negative. So if you do not put parentheses in, your calculator doesn't know that you actually want to square the negative with it. So when you put a number in your calculator that you are trying to square, make sure there's parentheses, or when you square a number, what kind of answer will you always get, positive or negative? Positive. So does it matter if you square negative 27 or positive 27? No, so if you're squaring a number, if you type it in, you can always just make it positive, you'll get the same answer, and then you won't have a negative problem. Alright, back to the problem there. What's negative 18 plus 729? 711. There you go. And that's the output. Alright, last one on the front. Hopefully none of those are too complicated, hurting your head too much. F of negative 2 to the h of negative 2 power. So let's scroll back up. Let's find f of negative 2 to start. We'll have negative 2 again in parentheses in the quantity squared minus 3. What does that give you as an output? Negative 2 squared minus 3. 1, right? 4 minus 3 is 1. Okay, now we need to find h of negative 2. Yeah, so negative 5 times negative 2 is positive 10, minus 7 is 3. Well, all I want you to find is f of negative 2, which is 1, to the h of negative 2 power, and 1 cubed is 1. Alright, not too challenging. Did you like my note on the bottom of the page? It says we're going to have a flip over for more fun with functions. That's because there's a little bit of fun in every function, right? I like cringe saying that. My mom used to say things like that, and she was a math teacher. And I like vowed, I'm not going to be like my mom. And then look, here I am. So, she would be proud. It's a little scary, but it's okay. What's the difference on the back? What do you see as a difference here? There are X's. There's not numbers. So we're going to see this with something else next week. So when we're doing functions here, if there's a numerical or a number input, like the front, we should get a number answer. when I have x's here, my answer should be in terms of x. We're not going to be getting a number answer. We're going to be getting a new equation or a new expression. So, again, we're going to start pretty simple here. 2 times f of x. So, let's see. I'm going to write 2. Now, here, I'm just going to put in parentheses the function, bless you, of f of x squared minus 3. And then I'm going to simplify, get rid of the parentheses. So I'm going to distribute, and my equation will be 2x cubed minus 6. Here you go. Not hard. I created a new equation, 2 times the original function f of x. All right, let's try a different one. H of x, the quantity squared. All right, so first let's put this in parentheses. Let's write negative 5x minus 7 squared. What do I do with this? What do I do, Lauren? Yeah, I have to write it twice. Now, if you were thinking in your head or you already started to write that, shame on you. Don't ever do that again. We've talked about this. We did this in the summer assignment. We talked about this when we factored and did different things. Exponent rules. I can't just distribute the exponent in here. If I'm squaring a whole quantity with variables, I have to write it twice. Okay? So now I'm going to FOIL. And most of the time when I FOIL in here, unless it's going to be complicated, I just kind of end up writing the final answer because we can mostly do this in our heads. So let's see, negative 5 times negative 5 is positive 25x squared. 35x plus 35x is 70x plus 49. So there's your new equation. If you need to write out another intermediate step, that's fine. But we can add 35 and 35 in our heads. Good so far? Those were 2 simple ones. Let's make them a little bit more, not too complicated, but a little bit more. F of x minus h of x. So when we subtract here, I want you to take f of x, which is x squared minus 3, and we're going to subtract the other function. Now, I want you to put h of x in parentheses. In fact, we probably could put both functions in parentheses, at least for the first step. And the reason I'm going to have you do that is because what do I have to do with this minus sign? Do what? Distribute it. All right? That's going to give me a very different answer than if I wrote just minus negative 5x minus 7. Because what's going to happen if you don't put parentheses is this sign will change correctly, but that one won't on the negative 7. And you'll forget that you have to distribute the negative to that term. So make sure you put your quantities in parentheses. All right, so now we have x squared minus 3 plus 5x plus 7. Now we need to collect like terms and rearrange that. Do you remember what it's called when we write exponents from highest to lowest? It starts with an S, some form. Standard form. So typically we like to write polynomials in standard form. So we write the x squared first, and then the x term, so plus 5x. And how do the constants combine? 4. There you go. So the subtraction part was not that much. Let's see. H of x times f of x. So again, put them in parentheses to start. Negative 5x minus 7 times x squared minus 3. And all we have to do is distribute. I think we need to write out all the steps this time. So we have negative 5x cubed plus 15x minus 7x squared and plus 21. All right, how do I rewrite this? What is standard form of this equation? What will go first? Negative 5x cubed, and then what? Which one? The squared. Minus 7x squared. I've heard you guys talk before. You're allowed, it's okay. I won't get mad like right now. Later in the year, standard form will matter more. If you left the first one as your answer, that's okay. Just know that I write all my answers in standard form if you're checking on the key or your work. Okay. Now we did multiplication, we did subtraction, I think. We can do addition. We actually can divide these, but we don't know how yet. We're going to learn later in the year how to divide polynomials that have exponents and variables in them. But we will get there at some point this year. We just can't do division now. Last one. We got all three functions. So we're going to take 3 times h of x. So we'll write it down there. Plus f of x. So plus x squared minus 3. And then, oh no, minus. I'm sorry, I made a mistake. Minus x squared minus 3. And then plus k of 0. What's k of 0? Negative 3 right here. So I'm going to put, just for now, the negative 3 in parentheses because I put everything else in parentheses. Now we'll get rid of them. So we'll distribute. 3 times h of x would give me negative 15x minus 21. And then I distribute my negative. So minus x squared plus 3. And then which sign do I get for the last one here? Minus 3. Yeah, plus and negative is just like a subtraction. And all we have left to do is combine like terms. So the easy one is plus 3 minus 3. Those cancel away. All right, my negative x squared first. My minus 15x next. Minus 21. And so that's a little more involved in the front, but it's really not bad, right? All right, last two. There's 3 on the bottom. We're gonna pick 2 of them. Would you like to do A or B? B? Okay, let's do B. A is just like it, and then we'll do C. So it says we're given a function r of x equals 5 plus 7x. Find x if r of 0.5x minus 1 is 33. All right, what do you think we need to do here? What do I have to do with this stuff in the parentheses, do you think? Yeah, I'm going to input that into the original function for x. So let's start there. I have the 5. I still have to write the 5 plus 7. Now, in place of the x, I'm going to put 0.5x minus 1. What do I have to do next? I still have one more thing to write. I'm trying to find x, and what does it have to be equal to? 33. So I want to know when the output, the answer is 33, what input for this function gives me the value. So now all we have to do is distribute and solve. So the 5 stays the same. 7 times 0.5 is 3.5x minus 7. Okay. 5 minus 7 is negative 2. So I'll have 3.5x minus 2 is 33. I move the 2 over, I get 35. So 3.5x is 35. And what's x? 33, I'm sorry, no. 35 divided by 3.5. 10. There you go. Does that process make sense okay? So if I have something kind of funky in the parentheses, I still have to put it in for the input. So it's the same as kind of that first problem we did, but more complicated. Last one, C. We're almost there. We can do it. I have a function. A of x is 4x squared plus minus 2x. Simplify an expression for a of x plus b. We're not solving anything this time. We're simply using x plus b as the input and then simplifying the expression. So let's do it. We have 4 x plus b squared minus 2 x plus b. Where should I start? X plus b squared, right? How do I redo x plus b squared? Rewrite it twice. Then x plus b, x plus b. Now I'm going to stick the 4 out in front, and I'm actually going to distribute the negative 2 over here just to simplify that part already. So I'll have minus 2x minus 2b on the end. All right. So that 4 comes in front. Let's FOIL. Let's distribute in like this pink part. And then the rest of it will be easy. It'll just be collecting like terms. So x times x is x squared. We have plus bx plus bx. How many bx's am I adding there? 2 of them. So plus 2bx and then b squared. So minus 2x minus 2b. Alright. So all I have left to do is to get rid of the parentheses and see if I can combine like terms. So I'll distribute and get 4x squared plus 8bx plus 4b squared. Let's see if I can squeeze it in. Minus 2x minus 2b. Does this part collect any like terms? No, so it actually looks worse than how we started. But that's the answer. That's the simplified, doesn't look really simplified. Good. So it's not much harder than function notation, right? It's not that bad. Good. No feedback. I'm assuming then you're good. If you don't tell me, I'm just going to assume. Which is maybe not a good thing. But I had an English teacher in 9th grade. Her name was Mrs. Kuzma. She was a nice lady. We had overhead projectors. You know what overhead projectors are? Yeah, we didn't have these things. And actually, I think we had one in the whole school, but it was like on a cart. And like teachers had to like sign it out from the library. But anyway, so we had an overhead projector. And like there's this saying about like, you know what happens when you assume. Like, do you know what it is? Yes? Okay, hold on. I'll turn the video off.